are distinguished as a medium of exchange, a unit of account, a store of value, and occasionally a standard of deferred payment. We have 1 rupee, which is equivalent to 100 paise. It's the same as 1 pula is equivalent to 100 thebe, or 1 rand is equal to 100 cent. In Africa, we have 1 dinar, which is equivalent to 100 kwais. You can find the examples at number 169 and number 179. Money is being replaced by forms of money. It's been replaced by forms of money such as cryptocurrency. For example, Bitcoin. We can invest in gold, silver, or oil. NB, money is also called many other names like currency and cash, currency or cash, and the currency value and slogan differs in different countries. Respect is something in life that is more valuable than money. That's what you're supposed to bear in your mind. And that there are 3 types of income, which are the following. Roman figure number 1, earned income. In brackets, open brackets, highest tax income, close bracket. You are working for the money. Like for instance, the job, this is earned income. You are getting what is called earned income. Roman figure number 2, portfolio. In brackets, put capital gains. With this type of income, you buy low and sell higher. Like you can buy something at low price and you sell it at a high price. Roman figure number 3, passive income. In brackets, cash flow. With this type of income is not taxed, and the rich doesn't work for a job but has assets that generate them income. Note, the government taxes on what you earn, taxes on what you buy, and taxes on what you own. Debt and taxes makes the poor and the middle class poor, but makes the rich wealthier. The rich are entrepreneurs and the poor are employees. Entrepreneurial is the mindset, skill set, and some settings and a set of rules. As you can study this chart there, you see this one. There is another one which is called income statement. Another one is balance sheet. With the one for income statement, the one that you receive your income, you can receive your income from a job or somebody paying you. If you are a rich person, you get it from somebody who's working for a job. He will be getting this money as income. So this money will get in as income, and the person just spend it as expenses. This belongs to the poor person. As you can see, that arrow shoots out as expenses. The person gets the money and they spend it straight away. Gets the money, spend it. That's what they do. They don't have any other type of business aside that generates money, another type of income for them. So they get this money from a job and they spend it. Every month, that's what they do. We also have this income. We get the income and we take it to liabilities. The liabilities, the ones that takes out money from our pocket. Then we take them to expenses. Liabilities take out money from our pocket, and then we end up spending this money as expenses. These ones, they fall under the middle class. Liabilities such as cars, houses, they are liabilities because they will end up taking out money out of your pocket. Because the house, you will end up fixing it, paying water bills, and a lot of bills in there. With the car, you end up paying the petrol, servicing it, fixing it. So you end up spending. So these ones, they fall under the middle class. And most of these middle class people are the people that work for the government. And they get to a lot of loans because of the lot of spending they get into. Because they will be after the rat race, We also have income, then is taken to asset. Like this income is taken to asset and it goes to the rich and back to the income. So this one is it goes along with the rich. The rich will get the income from other people as it gets into their assets. Assets such as the houses that they have rent, and it goes back to income as they get to pay other people in other work, as they get in their business, as they get to give back the money again through their assets. So the money rotates that way for the riches, or for the rich people through the assets. So this is how the rich people get more rich, by getting involved into assets or getting to buy assets that will generate them money even when they are sleeping or even when they are away from their work. Income is money in brackets or some equivalent value that an individual or business receives, usually in exchange for providing a good or service or through investing capital. Income is usually funded day-to-day expenditures. For individuals, income is most often received in the form of wages or salary. And B, you can create and work on your idea that you think the world is in need and you get paid for it. You get income for that, B, expenses, the cost or care required for something. C, liabilities are things that a person or company owns, usually a sum of money. Liabilities are settled over time through the transfer of economic benefits, including money, goods, or services. Liabilities take money out of your pocket. For example of liabilities include bank debt, mortgage debt, money owed to suppliers, in brackets, account payable, wages owed, taxes owed. And B, liabilities are legal obligation or debt. D, assets are resources with economic value that an individual, corporation, or country owns or control with the expectation that they will provide a future benefit. Examples of assets are cash, inventory, office equipment, investments, machinery, real estate, company-owned vehicles. Liabilities takes money out of your pocket while assets put money in your pocket. Quote, Robert Kiyosaki. Multiples of 4, 6, 7, 8, and 9. Those are the multiples. A student knowing the multiples of 1 till 10 will make counting easy for him or her. Most students get stuck whenever they are counting the above multiples. They will sometimes say out the wrong numbers. They will sometimes say out the wrong numbers. The following are steps to follow or questions that a student must ask and answer himself or herself in order to count or say out the above multiples without difficulties. Roman figure number 1. What is the next tenth? What is the next tenth? That's what the student must ask him or herself. That's the first thing he must ask him or herself. The second, Roman figure number 2. What number do we need to the next tenth? Roman figure number 3. What number are we remaining with? Roman figure number 4. Add the 10th number with the remaining to form the next number of the multiple. For example, when you are counting the multiples of 6, it's 6, 12, 18. We must at least know the first 3 numbers like 7, 14, 21, 8, 16, 24. For 9, 18, 27. We must get to know at least those 3 multiples to our third finger. Okay? When you are counting these multiples, we must always see that we use our fingers so that it wouldn't be confusing when we are getting to dividing. So that way it will be easy for you to get to know the multiples. This is another video that I've recorded that shows you how to do it. So get to check it out as you get to make it. You know what I'm saying? Because if you get to just make them stick in your mind and you think that you are going to just say them out whenever you want to use them or say them out or get to calculate the number that wants you to count out the multiples, then you won't say them out or you end up forgetting them with time. So the best way for you to get to know them forever is by using this kind of formula or way of counting. You know what I'm saying? So get to check out that video. Note, the opposite of multiplication is division. The opposite of addition is subtraction. Mathematics will never be easy and fun if the student doesn't know how to use the math operations. Operations, quote Nikov Nkwe. Operations, we are talking about addition, subtraction, multiplication, division. Those are the operations. Get to know them, familiarize yourself with them, as you get going. Rounding off. When you are rounding to a given place value, you ought to look at the number in front or on the right hand side. When you are rounding to a given place value, you ought to look at the number in front or on the right hand side. If it is between 9 and 5, then you increase the place value with 1 until then all the numbers to a unit turn into zeros. The same rule is used when the number in front or on the right hand side is 1 or 2 or 3 or 4, but the nearest place value given doesn't change. What we mean is that, for example, 1,455 to the nearest 1,000, there you have 1,000. You put your finger on top of 1,000. 1,000 means you put your finger on top of 1. When you put your finger on top of 1, you look at the number in front. The number in front is not that active, meaning that it's less than 5. It's 4, 5, is 4, 3, 2, 1. So it won't change this 1 of 1,000. So 1 of 1,000, it will remain 1, and the rest of the numbers on the right side will remain zeros. Okay, That's an example. That's how it is. Place value. You're supposed to know the place value. Place value. The place value, for now, you getting to know the place value. Avoid this the numbers after the decimal point. But you must bear in your mind that it means those are cents or tables. Okay? Or the numbers less than the numbers before the decimal point. So after the decimal point, going to our left side, we have the unit. The unit followed by tens. It's a second number from the unit. We also have the thousand. We also have the hundred, which is the third number from the decimal number. Sometimes you might think that there is no decimal number when it's written 564. Just bear in your mind that there's always a decimal number when you are talking about money. Then that way it will be 564.00. Okay, with the money. The fourth number, it will be 1,000. The fifth number, it will be 10,000. The sixth number, it will be 100,000. The seventh number, it will be 1,000,000, etc. Okay, that's how it gets to move. So you're supposed to know how this place value is, or how these numbers are placed, in order for you to know how to read them out, or else it's going to give you difficulties in reading them out. The place value itself, it helps us to know how to read out the numbers. Okay? Note, centillion is the largest illion with an official name in English, and it is equal to 1 followed by 303 zeros. Graham numbers is the largest number which can be written with conventional notation. So you will hear other people saying that the numbers ended trillion, or the number, they will think that the numbers ended billion. Just bear in your mind that counting of numbers never ends. It keeps on going, It keeps on going. Like we have centillion, we have gogullion, Types of biggest numbers out there, And we have Graham, which is an uncountable noun. Imagine if we had to count sand, or we had to count rice, or we had to count small maize in our maize mill. We move to number one. Number one, list the Roman figure from 1 till 12. 1 till 12. Roman numerals or figure. Roman numerals or figure, or Roman figure. You will choose how you will call it out. Whether you call it out Roman figure, or you call it out Roman numerals. 1 is equals to I, 2 is equals to 2 I's, 3 is equals to 3 I's, and 4 is equals to IV. 5 is equals to V, 6 is equals to VI, 7 is equals to 7 is VII, 8 is V followed by 3I, 9 is I followed by X, 10 is X, 11 is XI, 12 is X followed by 2I, So for this Roman numerals or Roman figures not to be tricky for you guys, you're supposed to bear in your mind that 5 is V and 10 is X. So whenever you bear all this in your mind that 5 is V, then you know that when we reduce it like negative, we reduce it once in our left hand side, then we will have 4. Then we will know that when we reduce it with 1, it will be IV. when we reduce it with 1, taking it as if like we are having v, then a negative on the other side, then we will have a negative 1, it will give us 4, like IV. And when we are taking it to the, like, this number line, when you're taking it to our right hand side, you will know that we are increasing it. Then you will know that we will have VI, like we have increased this V with Roman figure 1, and then we will have VI. So with 7 we will know that we have VII, and with 8 we will have VIII. So we never had 4 I's, we never had 5 I's, etc. So we always have to have 4 SIV, 1 SI, 2 S, 2 I's, 3 S, 3 I's. Then we get to have IVs, IV S4, and after 8, getting back to 8, after 8 we know we have V, and followed by 3 I's. We will never have 4 I's. So we will be reversing that X to make it 9 by writing IV, IX. Then we will know that we have 9 by reversing X, which is 10. We will have, by reducing X with I by writing I on the left hand side, then we will know that we have IX, which is 9. Then X as 10, then XI, increasing X, the 10X by I, it will give us 11. Then XII, it will give us 12, etc. So most of the time, students in primary level will be asked between those Roman figures, And Roman figures, these are that which were used by to name the kings and the queens, like King Nikov the first, King Nikov the second, This is used also sometimes with the time, So you're supposed to know the Roman figures. Number 2, what is an integer? An integer is a whole number or any of the natural numbers, in brackets, positive or negative, or 0, e.g. 0, -4, 2. These are integer. They are whole numbers because they are not fractions, and they are not of decimal numbers, So they are whole numbers, they are integer. Number 3, what is a rational number? A rational number is an integer or a fraction. It's either a rational number is an integer or a fraction. It's just a number or a fraction. And a fraction, remember, it's an opposite of a rational number. So we continue reading. The set of rational numbers is closed under all 4 basic operations that is given any 2 rational number, in brackets, as long as we don't divide by 0. Okay? Note, all rational numbers that are finite limited in quantity are rational numbers. That's what you're supposed to bear in your mind. Number 4, what is an irrational number? An irrational number is a number that cannot be written as a fraction. In decimal, it never ends or repeats. The decimal value continues forever without patterns, e.g. square root, f2, or pi. Okay? Note, sometimes pi is written as 3.14, but we look deep at it. But if we look deep at it, it is actually 3.1415926 5, 3, 5, 8, 9, 7, 3, 2, 3, 8, 4, etc. And this goes on for somewhere around trillion digit. So we chose to just write it as 3.14, or we can sometimes write it as 22/7, which when we turn it into a decimal will also give us that. So 22/7 as a fraction and 3.14 as a decimal. That will be our pi. Number 5, that will be about number 4, that will be our pi, and it is usually used in a circle or calculating a circle. Okay. Number 5, what is an even number? An even number is a number that is divided by 2 and it does not give a remainder. The part that it doesn't give a remainder, it's important. We cannot just say an even number is a number that is divided by 2 and we just keep quiet there, So it does not give a remainder. For example, 2, 4, 6. Number 6, what is an odd number? An odd number is a number that is divided by 2 and it gives a remainder. For example, 3, 5, 7, 9, 11. They can be divided by 2 and they will give you a remainder of 1. Number 7, what is a prime number? A prime number are whole numbers greater than 1 that have only 2 factors, -1 and the number itself. Another definition, a prime number is an integer that has no integral factor but itself and 1. And it shall be greater than 1. For example, 2, 3, 7, 11. For example, you can check it out at number 164. Number 8, what are triangle numbers? A triangle number are numbers that when arranged such that each dot is at an equal distance from its neighbor, they will form an equilateral triangle. For example, 1, like you see that dot, it begins with 1, then we put the 2 dots between, it will give us 3. The following line of dots, we put 3 dots. Since they are both line, we gave 2 dots, and the first line it was 1 dot. Then we put 3 dots, then all the dots will be 6. The following line we will be putting 4 dots, and that such that it will be such that the triangular numbers are numbers that when arranged such that each dot is equal distance from each neighbor. Then it will give us 10, then 15, then etc. As you keep on increasing the numbers with 1, Note, the isosceles triangle is a triangle with 2 equal sides. Isosceles triangle is that of 2 equal sides. That, as you can see there, we have a triangle, then it's of 2 equal sides. The below side is small. It's not equal as the ones that we have shown with those small lines. The scalene triangle is a triangle with no 2 sides or equal length. It's not equal at all. All of it is just with different angles or different length of size, That's a scalene. It's of different length of size. The equilateral triangle is a 3-sided regular polygon. It's regular, it's equal, Equilateral triangle is of equal sides. Right angle triangle is a triangle with 90 degrees. It have a perpendicular line inside which makes up 90 degrees. It's a right angle triangle. Number 9, What are square numbers? The product of number of quantity multiplied by itself. Thus 64 is the square of 8. The square if a plus b is a2 plus 2ab plus b2. For example, 2 times 2, it will give us 4. 4 times 4, it will give us 16. For us to know square numbers, it means that you're supposed to just multiply that number by itself, and then it will give you a square number. That's it. Like 1 times 1, it will be 1. 2 times 2, it will be 4. 4, we get to 3, we move with them along, we don't skip any number. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. Just like that, what I'm saying? For example, you can see the example at number 143. Number 10, what is square root? What is square root? Square root is a number that when multiplied by itself equals a given number. It's a square root. Square root almost equals to square numbers, just that the square root is you write the power itself in a calculator, or it has this power. Now it gives you a square root of that number. On a calculator, you'll be pressing the square root itself, after writing such a number, and it will give out the square root of such a number. Number 11. What does the symbol dash mean? The symbol dash means that the number on the left side is bigger or greater than the number on the right side. That's what it means. For example, 8 is bigger than 5. So when this greater than it have opened, it is greater than 5, greater than it have opened on the left hand side, it means that that number is greater than the one on the right hand side. Number 12, what does the symbol dash mean? The symbol dash means that the number on the right side is bigger or greater than the number on the left side. For example, 23 is less than 37, meaning that the number on the right hand side here is bigger than the one on the left hand side. So since there's this symbol have opened on the right hand side, it means that the side that it has opened at is the one that is big. Okay, that's how you're supposed to figure out, or that's how you're supposed to recognize, or that's how you're supposed to put the symbol if you know which side is bigger than the other side. So you put that sign very well. It shouldn't be tricky to you, So if they're equal, you just put an equal sign. Number 13. What is the difference between the word estimate and the word express in relation to mathematics? Estimate is a rough calculation of the value, number, quantity, or extent of something. For example, estimate to the nearest 10, e.g. 58 times 89. When we estimate 58 to the nearest 10, it will give us 60, because 8 is a positive number or a strong number. It will turn 5 into 6. As this 8 turns into 0, then we'll have 60. With 89, 9 is a positive number. We will turn this 8 into 9, then we'll have 90. As this 9 remains 0, so we'll have 90. From there, we say 60 times 90 is equals to 540. That's how we do it, okay? This kind of numbers, they will sometimes give students difficulties. That's how we get to do it there, you know what I'm saying? Estimate to the nearest 100. We are going to estimate the following to the nearest 100. So these numbers they are made up of tenth and they are made up of units and tenth. There is no other number above that. So we have 58 times 89. Both of them, looking at them in front, they will give us 100, okay? Because 58, there was a number 0 in front of 58, like in front of on the left hand side of 5, we had 0. So this 5 will turn this 0 into 1. We will have 1000. We will have 100. It's the same thing with 89. With 8 on the left hand side of 8, we had zeros. Then so this 8 will turn this 0 into 1. So we'll have 100 again. So then we continue 100 times 100. How can we do it? Obviously, we will know that we have a decimal point in front of 100. So we move it 2 times to the right, the decimal point, then we will end up having a 10,000. Okay? Number 14, define the term sum. Sum means you shall add the given numbers. For example, 6 plus 5 is equals to 11. That's what it means, you know, you're supposed to add. In computer studies, the computer uses the binary numbers which are made up of ones and zeros, and the following table shows the computer and the following table shows how the computer and its numbers communicate or do what the programmer wants it to do at what time and at what rate during coding. Note, binary number is another way of saying base 2 because there are only 2 symbols to represent numbers. 2 doesn't exist. Instead, we use 10 to represent 2. Decimal numbers. The system we use every day is based on 10 digits. In brackets, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Meaning that we don't have 10, 11, 12. So we have those 10 digits and we get to make them to create other numbers. With this symbol, we can represent any quantity. It is called base 10 because it uses 10 symbols. When we write decimal, in brackets, base 10 numbers, we use a positional symbol notation symbol. We use positional system notational system. When we count in base 10, we count starting with 0 and going up to 9 in order, and once we reach the last symbol, we create a new replacement in front of the first and count that up, like 8, 9, 10, 11, 12, 19, 20, etc. So that's how mathematics work in computer, binary addition, 0 plus 0, it will give out 0, you carry 0. Case 2, 0 plus 1, you have 1, you carry 0. 1 plus 0, you give out the answer of 1, carry 0. Case number 4, 1 plus 1 is equals to 0, carry 0. So that's how it differs. You will familiarize yourself with that. If you are doing computer studies, that's what you're supposed to know, how the programming works, or how mathematics adds up or subtract or multiply in computer base 10, That's, you can find also this example binary against the decimal. You can familiarize yourself with them. Note, 0 is the identity element. The value of the number does not change when 0 is added. For example, 13 plus 0 is equals to 13. Number 15. Define the term difference in relation to mathematics. Difference means you shall compare how the numbers differ and you shall subtract the given numbers. For example, 17 minus 9 is equals to 8. The difference just means just reduce, just subtract, You will get to find a lot of numbers that need you to subtract, or you just read out a certain math problem and you wouldn't know whether to subtract or add or which symbol to use, That itself is important. You're supposed to familiarize yourself with getting to know what kind of symbol you're supposed to use, or math operation symbol you're supposed to use, as mathematics gets easy for you to do, or to solve, Number 16. Define the term product in relation to mathematics and entrepreneurship. Product means the number or sum obtained by adding one number or quantity to itself as many times as there are units in another number, thus multiplying the given numbers. For example, 6 times 9 is equals to 54. Okay? For example, you can find it at number 153, and you can also find it at number 181. Multiplying of two-digit number has an addition part in which the bottom row units are in line with the first row tenth before we reach an answer. Okay? So that's what you're supposed to know when you are multiplying. Some people wouldn't know that when you are having a number of 2 by 2, after multiplying the first number on the second row, you're supposed to multiply the second number on the second row for the next column on your left hand side, So that's an example there, you know what I'm saying? What we did there, for example, 2 by 2 numbers, 0 times 0, anything times 0, you're supposed to bear in your mind that 0 times 0, anything times 0 is 0, is equals to 0, regardless of what might happen, you know what I'm saying? 0 times 0, 0 times 3, it will give you 0, 0 times 4, it will give you 0, 3 times 3, it will give you 9, so that 3 is supposed to, the answer starting from that 3, it's supposed to be in row or in column with that number down there, So 3 times 3 it will be 9. That's where we write our 9 in line down there, Then we go to 3 times 4. 3 times 4, it will give us 12. That's where we write our 12 there. Then this is the column where we get to add there, you know what I'm saying? We put a line, we get to add. 0 plus 0 goes down. 0 plus 9, 9 goes down. 2 goes down, 1 goes down. That will be the answer. The same as the one with from 84 times 72. We started by saying 2 times 4 it will be 8. 2 times 8 it will be 16. We put 16. So the last number after multiplying, there will be no way to put it. So there will be no need for us to carry. So that's what you're supposed to bear in your mind. The last number on your left hand side, it makes us to write the number the way it is. But as we keep on going, it will make us carry the number. For example, if we had 2 times 6, you will write 2. You will write 2 times 6, it will give us 12. Then we will write 2 carry 1 on top of 8. So it's not like that. So we continue. We are done with 2, multiplying 2. Then we move to 7. 7 times 4, the number will go down there along in the same line with, in the same column with 7. 7 times 4, it will give us 7, 14, 21, 28. We will write 8, then we carry 2. We carry 2 on top of, 1. Okay? 7 times 8, 8, 16, 24, 28. 8, 16, 24, 32, 40, 48, 56. 56. We will have 56 there. So we have 56. 8 goes down. 6 plus 8. Get all that done. You're supposed to get it done. That was an example of how that's supposed to be done. Since nothing is clear right now, I can write, and it happens that it is not clear to you. So let's pass with that one. You'll get to understand when you are writing down, and not with this kind of video. Note, by it means you must multiply two numbers to find the shapes area. For example, you can find the example at number 94 and also at number 158. Number 17, define the term quotient. The ratio of two quantities to be divided is called quotient. For example, 36 divided by 6 is equals to 6. Here, you're supposed to understand that you are not dividing 6 by 36, but instead we are dividing 36 by 6, and it's going to give us 6. So, for you to get to know how to do this, or how to find out the answer quickly, when you are told 6, when you are told 36 divided by 6, you will be counting out the multiples with your fingers, then you stop at 36. And by saying 6, 12, 18, 24, 30, 36, and your fingers will be 6, that's the answer. That way it will be quick for you to know the remainder. If you were told that 40 divided by 6, that way you will know that it's 6 divided by 4. That's how quickly you can deal with dividing when you get to get the answer, whether it has a remainder or not. You know what I'm saying? So you can find the example at Roman figure number 108. Number 18, Botmas means brackets of. Did this BO, it means brackets of. D, it means division, multiplication. A, it means addition. S, it means subtraction. Note, division and multiplication always comes first, and whichever comes between the two goes first. Addition and subtraction always comes second, and whichever comes between the two goes first. We shall check out number 41, 60, and 189 to get the examples and to find out what we actually mean, and it becomes clear to your brain, you know what I'm saying? Or it becomes clear to your understanding as you get to make it in mathematics. Number 19, there are 3 types of law used in mathematics, and they are as follows. A, what is commutative law? You must know this kind of laws, and mostly you will be given different numbers, and you will be asked what kind of law is it of the numbers that will be given, and the other students wouldn't know. So you're supposed to know what kind of law, or the difference between all these 3 laws, you know what I'm saying? A, we have for commutative law. What is commutative law? Commutative law is the law that allows us to change the order of given numbers when we add or multiply 2 numbers. When we add or multiply 2 numbers. Like Roman figure number 1, you can see them when we are adding 4 plus 5, we got 9. You can still mix them, or we say 5 plus 4, still we are going to get 9. In Roman figure number 2, when we are multiplying, we test it when we are multiplying. So 3 times 7, it will give us 27. Or 7 times 3, it will give us 20. 3 times 7, it will give us 21, or 7 times 3 will also give us 21. No matter how we flip-flop them, or we mix them, or we overlap them, they will always give us the same number. And this kind of law, it is called the commutative law. You know what I'm saying? Note of, in brackets, of a binary operation independent of order, as in, for example, A times B is equals to B times A. Commutative law. Commutative is relative to exchange or interchangeable or reciprocal. Okay? The mixing of those kind of numbers. That's what it means. You know what I'm saying? No matter which one is at which side, it will always give the same number as long as we are multiplying or we are adding. That's what it means. You know what I'm saying? Number B, what is associative law? The associative law allows you to add or multiply numbers in any order, whether in brackets or not in brackets. Okay? Note, we do not change the position of numbers. Always the numbers are supposed to be the way they are, On the other side of the equal sign, from the other side of the equal sign, the numbers are supposed to be the same, The only thing that we change is the brackets. So we remove the brackets. We might have positioned our brackets on the first two numbers, on the other side of the equal sign, on the other side of the equal sign. Then we get to position the brackets on the last two numbers from our right hand side. That's what it means. Like you can see there, we have in Roman figure number 1, we had 7 plus 5 plus 4. On the other side, still we have 7 plus 5 plus 4. And the only thing we did was to move the brackets. At first, we positioned them with 5 plus 4, and then on the other side, we positioned them from the left-hand side with 7 plus 5. And still, all of them, they give us 16, you know what I'm saying? Like we also did there with Roman figure number 2, 19 plus 7 plus 11, still is the same thing. The other side, 19 plus 7 plus 11, The only thing is that we changed the brackets, we moved the brackets, We first position them on our left-hand side with 19 plus 7, On the other side of the equal sign, we position them with 7 plus 11, That's what we did. And they all give us the same answer, which is 37. Number C, what is distributive law? Distributive law is applied when we multiply the sum of different or two numbers in a bracket. The answer will be the same whether you put distributive, you first distribute the multiplication and then add or subtract. That's how you see it in Roman figure number 1. 4 times that which is in bracket, you will multiply it and it will give out the answer, It means that you will say those that are in brackets, you get to solve them first. Then obviously you get to say 5 plus 8, it will give out 13. Then 4 times 13, it will give out 52. Or you can do it by saying 4 times 5 plus 4 times 8. So this way, the way it's written on this side is the same as on the first side, where we say 4 times, then in brackets 5 plus 8, because that which is in bracket, it means that it will be multiplied by the one that is outside the brackets, We can even write it as 4 in brackets, 4 open brackets, 5 plus 8, close brackets. Whether we wrote a multiply sign or not, still we get to know that we have multiply sign. multiplication sign in front of form, So you will find that you have math problem which don't have form. Such is for you to just apply, That's it, basically. So 4 times 5, you get 24. Then 4 times 8, you get 32. Then you add those two, they will give you 52. It's the same thing. We move on to Roman figure number 2. 6 times 7, you can, it means that it's 6 times 7 and 6 times 9. So the way it's written, the ones that are in brackets, we deal with them first. 7 plus 9, it will be 63. Then 63 times 6, then it will give out 378. Or we can do it like this. 6 times 7. Then we put a addition sign. Then we say 6 times 9. So 6 times 7, it will give us 42 plus 6 times 9, which is 54. The final answer, it will be 378. So still is the same thing as the first one we just mentioned, or we just stated out or read out, you know what I'm saying? Number 20, what is a polygon? A polygon is a closed two-dimensional figure made up of lines, segments, but not curved. They are not curved. They have these corners, small corners, you know what I'm saying? They are straight and they have these small corners. The term polygon originates from the Greek word poly, meaning many, and gon, meaning angles. Note, circles, three-dimensional object, any shape that includes curves and any shape that aren't closed are not polygons. Okay? That's what you're supposed to bear in your mind, that circles, three-dimensional object, we mean like a 3D object, like you can see the back of a shape. Those are three-dimensional objects. Any shape that includes curves and any shape that aren't closed, meaning that it's open, are not polygons. That's what you're supposed to bear in your mind. Okay? Types of polygons. Depending on the sides and angles, the polygons are classified into different types, namely 1. Regular polygon, 2. Irregular polygon, 3. Convex polygon, 4. Concave polygon. Regular polygon. A regular polygon is a polygon in which all the interior angles are equal and also all the sides are equal. There are different types of regular polygon. Remember, a regular polygon is a polygon in which all the interior angles are equal and also all the sides are equal. They are called regular polygons. And these polygons are as follows. These are a rectangle or trigon. An equilateral triangle is a regular polygon with 3 equal sides, length, and 3 equal angles. As you can see, the triangle there. A quadrilateral tetragon. A quadrilateral is a regular polygon with 4 angles and 4 sides. 4 angles and 4 sides. It's called a quadrilateral. Example of quadrilaterals are as follows in order: kite, square, rectangle, rhombus, trapezium, parallelogon. For example, you can find an example at number 161. Pentagon. A polygon that has 5 equal sides and angles is called a pentagon. A pentagon. We have a Pentagon security force at the United States, you know what I'm saying? They call it Pentagon. We have hexagon. A hexagon, a regular polygon that has 6 equal sides and 6 equal angles, is called a hexagon. Heptagon, a regular polygon with 7 equal sides, length, and 7 same angles, is called a heptagon. Octagon. An octagon has 8 equal sides and 8 equal angles. The best real-life example of an octagon is the stop road sign. It's made up of 8 sides of that makes up of 8 equal sides and 8 equal angles. Nonagon has 9 equal sides and 9 same angles. It's called a nonagon. We have a handy subscribe, like, and share the video. Thank you very much.